So guys, we're on chapter 2, and let's talk a little bit about the law of conservation of mass. So what we're going to do for this sample problem is we're going to do number 19 from the law of conservation of mass questions that are at the end of the chapter. So we have xenon trioxide, so xenon and 3 oxygens. So for every 1 xenon, you're going to have 3 oxygens. And it looks like we have 7.32 grams of xenon for every 2.68 grams of oxygen in this compound, right? I need to know the mass of oxygen needed to convert 100 grams of xenon to xenon trioxide. So we could think of this as a ratio. So sort of like 7.32 grams of xenon for every 2.68 grams of oxygen, right? This is a consistent ratio. You're going to see this consistently when you are in the xenon trioxide compound. So then I say, well, what if I have 100 grams of xenon? How many grams of oxygen is this going to be? So we've all done the cross multiplication, right? So what you're going to do is you're going to multiply these two and multiply these two. So in my calculator, I mean, I could do this in my head. 100 times this, you move the decimal place over 2 times. That's going to be 268. And that's going to equal 7.32 times my question mark. So let's call this, well, since we already have an X in there, let's just keep my question mark, I guess, right? 7.32 times whatever that number is. So then to solve for my amount that's here, I divide both sides by 7.32. So 268 divided by 7.32, I get 36.6 grams of oxygen. So all I did here is there's a consistent ratio here. It looks like, and if you think about this, doesn't it look like there's about 3 times more mass of xenon for every oxygen? So it's about 3 times heavier. So my answer, if I'm trying to say I have 100 grams of xenon, I should have about 30-ish, right? So my answer makes sense. So I'll do a couple more law of conservation of masses, but I hope that that one helped. We are determining how much xenon or how much oxygen we need to react that xenon completely.